Hello everyone, welcome back to Pepcoding. So today we will discuss about Bellman code. It is an algorithm which we use to find out the shortest path. So first we'll understand what the question is saying and then we will try to code it. Alright. So see, we have been given two integers. The two integers which have been given to us are n and m, and n is the number of vertices which we are using, m is the number of edges. We are also given ai, bi and wi, where ai represents an edge from vertex ai, where ai and bi represent an edge from vertex ai to a vertex bi. Alright, and wi represents the weight of that edge. And our task is to find the shortest path from source to vertex to all other vertices. Okay, from source vertex to all other vertices. See now, over here we have been given a graph. What we need to do right now is that we need to be able to figure out, see, let us assume that our source given to us over here is 0. So we need to figure out what will be the shortest path to go from our source, that is 0, to all the vertices. Alright, so see how we'll do it. I'll just create this array. So 0, 1, 2, 3, 4, 5 and 6. Okay. So basically what we are doing is that we need to find out what will be the shortest path to travel from our source, which is 0 in this case, to all the other vertices present in the graph. So the first thing which I am saying is that right now let us assume it is infinity for all the other vertices. We will figure it out. So we will print it in the form of an array only. Okay, we will create an array where we will store all the distances, the shortest paths. But what about source to source? That is, if we want to go from 0 to 0, what will be the shortest path length? I am saying that the shortest path length to go from 0 to 0 is going to be 0 only. Now you will say that it can be negative also, since there are edge weights which are negative. But see why I am saying that it will not be negative and will only be 0. So if I have something like this, 0, 1, 2, 3, let's say this is 3, 4 and this is over here. So if I have 1, 10, 2, 4 and 5. Now see, if this is negative over here, then I'll calculate the values to go from 0 to 0. So I am saying it is 0 only. Go in a cycle now. So if I go in a cycle, what will it be? 1 plus minus 10 plus 2 plus minus 4 plus minus 5 and plus 1. So it will be a negative value. Then if I try to go in a cycle once again, it will be an even smaller value, and this will keep on repeating itself. What I mean is that if I try to go in a cycle to be able to find out the distance from my source to source, and since there are edge weights whose value is negative, so we will keep on decreasing this value with every cycle we take. So what happens is we will go into an infinite loop of cycles, and we will just keep on going in cycles and cycles and cycles to be able to find out the shortest path, which is not feasible obviously. So I am saying that to go from 0 to 0, the shortest path length will be 0 only. So over here I can easily put 0, right? This we will not change, this value cannot change, so I'm going to fix it over here. Okay, the next thing which we need to do is we need to figure out how we will be able to get the shortest path from from the source to our rest of the vertices. Alright, so let's see. For example, I want to go from 0 to 3. Okay, so this is 6. Another path which I can take for it is, one was 6, the other path which I can take is this also, which is 4 plus 7, 11 minus 8, that is 3. So the shortest path which we are taking is 3, right? And the path length is also 3. Okay. So Let's see. So what we need to do now is we need to be able to find out the shortest path in this manner only. It's not necessary that if I have only one edge, then the path will be the shortest. We just saw through our example that even if the path length is greater, the path can be the smallest one as well. Okay, on the basis of the cost or the basis of edge weight. All right. So now we need to figure out how to do this. Okay. So what I've done is that over here I have taken, let's say this is U, this is V, this is W, okay. So U is my first vertex, V is the second vertex, and weight is the edge weight between them. So I've taken this order. What you need to do is just take any order of your choice, alright, and fix it. Just use that order only and go in that order, and I am telling you that go for V minus 1 iterations. Okay, why we take V minus 1 iterations, we will discuss about this later on. Okay, so our question is, why do we take V minus 1 iterations? We will discuss about it, but later on. Right now, let's just take it as a fact and move with it. Okay, so what I'm going to do is, I am going to find out whether, let's say I have this array of path, and I'm checking if path of U plus weight is less than path of V. Okay, that only I need to check, that to go to my second vertex from a particular vertex. If I add the weight to this thing, will it be smaller? So if it is smaller than the previous path which I decided, then I'll update it. Okay, so if I go in this order, I'll tell you why I chose this specific order later on. Okay, so if I go in this order, see, I am asking if path of 4 which is infinity plus the weight which is 3 is less than infinity. It is not, so nothing will happen. Okay, we are taking V minus 1 iterations. Right now it is iteration number 1. So this we've done. Then I come here. Is path of 3 that is infinity plus weight that is 2 less than path of U that is this? No, so nothing will happen. Alright, then I'll check for this one. So infinity plus minus 2, is it less than infinity? No. Move to the next one. Infinity plus minus 8, is it less than infinity? No. Move to the next one. Then for 1 and 2 I'll check. Infinity plus 7, is it less than is this less than infinity? No. So now we'll go to the next one. Now I'm checking is path of 0, which is 0 plus weight that is 6 less than path of 3 which is infinity. Yes, it is. So what will I do? I will update this. Okay. So what we did was we updated this. Then go to the next one. Is path of 0 that is 0 plus 4 less than path of 1 that is infinity? Yes, so we will update this also. Okay, so right now only my iteration 1 is finished. Then I'll go for iteration number 2. If I'll go for iteration number 2, I'll check again. Path of 4 is infinity. Weight is 3. Is it less than path of 5? No, so we'll do nothing. Path of 3 is 6. Weight is 2. Is it less than path of 4? That is infinity. Yes, so we will update over here. Then path of 2 that is infinity plus minus 2. Is it less than path of 5? No, so we'll do nothing. Then again path of 2. Path of 2 is infinity plus minus 8. Is it less than path of 3? That is 6. Obviously not. So again we'll do nothing. So this will keep on going. We will do one more. See, path of 1 that is 4 plus weight that is 7. Is it less than path of 2? That is infinity. Yes. So we will go for 11. Similarly, we will complete for these 3 also. So iteration 2 will also be done. This we will do V minus 1 times. Over here we have 1, 2, 3, 4, 6 vertices. So we will do 5 iterations over here. Okay. And by the end of all the iterations, I will have my shortest path on each position of the array. Okay. Now, right now I did not do the complete dry run, right? I will do it just 1 minute. I will make a statement right now. Okay. And on the basis of that statement, we will continue. So the statement which I am making right now is that for every ith iteration, I will get the shortest path where path length will be equal to I. This is what I'm saying. This is my statement. That is, I'm saying, let's see, I'll explain with an example. I'll just put this over here. Okay. So what we are saying is that when we were going from 0 to 3, right? So this is 1 path length and this is 3. The path length is 3. So I am saying that in third iteration, I will get my shortest path to go from 0 to 3, where the path length will be 3 only. Okay. So over here we can see that our path length is 3. So I will be able to get this shortest path in my third iteration. So now we will do a dry run on the basis of this and we will figure out whether it is correct or not. Okay. So let's say we have infinity all over here. Okay. Just assume that in this array on all the positions I have put infinity here. Okay. So I had infinity, infinity, and infinity. So I am starting with iteration 1. Alright. So when we did the first iteration, none of these made any difference. Only these two were able to do something for me. Okay, I was only able to update my values on the basis of last two ones. So going for this one, path of 0, that is 0, plus 6 is less than path of 3, that is infinity. So it will be updated and it will become 6. But I am saying this is not the final value for it. I am saying the final value, the shortest path value, will come in my third iteration. Okay, so this is still the first iteration only. So after that, over here, path of 0, that is 0, plus 4 is less than path of 1. Yes, so I will update over here, I'll get 4. Okay. Then I go for my second iteration. I'll just change the color and we will work with it. Then over here, I'll check for 4 and 5. So 4 is also infinity. There's no use to check. Then I'll check for this one. So now I'll get 6 plus 2 is less than infinity. Okay, so path of 4 will now be updated. It will become 8. Okay. Then I come over here. Path of 2 is infinity only. So there's no need to work with it. Then path of 2 and 3. Path of 2 is infinity. No matter what I do, it cannot be less than path of 3, which is 6. So this also we don't need to check. Okay. Then I'll check over here. Path of 1 is 4 plus 7. Is it less than path of 2? That is infinity. Yes. So we will change over here. It will become 11. Then I'll check over here again. Path of 0. Here. Path of 0 is 0 plus 6. And over here also we have 6. So it is not less. Nothing will happen. Over here also we will not update. Now we are done with our second iteration. We will move on to the third iteration now. Now over here, path of 4. I have 8 plus 3. Is it less than path of 5? Yes. So over here I'll have 11. Okay. Then path of 3. I have path of 3, that is 6 plus 2. Is it less than path of 4? That is 8. No, so nothing will be updated. Then path of 2, that is 11 plus minus 2, that is 9. Is it less than path of 5, which is 11? Yes. So we will now update this and it will become 9. Okay. we need to check whether path of 3 will be updated. We are looking for it right now. Okay, then path of 2. Path of 2 is 11 plus minus 8. It is equal to 3. Is it less than path of 3? That is 6. Yes, so it is updated. So you can see that in the third iteration, we updated the value for going for path 0 to 3, which we found out that the shortest path was of length 3 only. Right? So now we are able to figure out that on the ith iteration, the shortest path which we found had the path length I. But now I am saying that right now I lied to you. Okay. That what I said about this statement was not the exact truth and it was not completely correct. Okay. It wasn't wrong, but it wasn't also completely correct. So see why did I say this? 1 second. We will talk about it. Okay. So the statement which I took over here was that in my ith iteration, here I said that in my ith iteration, the shortest path I will get when my path length is equal to I. Now what I am changing is I am saying that it is not exactly equal to I. It should be less than equal to I. Okay. The example which I took over here, the order which I took over here was supporting the one which said exactly equal to I. Okay, that is why I took this order. But now if I change the orders a little bit, let's say I'll just go in the reverse order. Okay, so this is 1, 2, 3, 4, 5, 6 and then over here. Okay, so now let's work with this order and we will see. Okay, we have this over here. Alright, I'll just correct it over here only. Should be less than equal to I. Okay, so now the first thing we are going to check for will be for 0. So path of 0 is 0 plus 4 is less than path of 1. We have iteration 1 right now. We'll check for third only, or let us check for another one. Let's check for 4. Okay, so over here this path is 8 and we have this path. So this is 4 plus 7, 11 minus 8, 3 plus 2, 5 and the path length is 4. So we'll check whether it comes in fourth. It should come in fourth or less than fourth iteration. Okay, the shortest path to go to 4. We'll check that. Alright, so let's see. We were working with this one. So the path, this will update and it will become 4 because it is less than infinity. Okay, then we check over here. 0 plus 6 is less than path of 3. Yes, so it becomes 6. Then I'll go over here. I'll check for path of 1. It is 4. So path of 1 plus 7. Is it less than path of 2? Yes, so it will update and become 11. Then path of 2, that is 11, plus minus 8. Is it less than path of 3? Yes. So in path of 3, I had 6. Now it is coming to be 8. Now see, earlier when we were working, we saw that it worked only in the third iteration. Now in the first iteration itself, I am able to update this value and it became 3 only now, right? Then we'll move up. Okay, we come to this part. So path of 2, that is 11, plus minus 2. Is it less than path of 5? Yes, so we will update path of 5 and it will become 9. Then over here, path of 3, that is 3, plus 2. Is it less than path of 4? Yes, so we will update and make it 5 over here. Okay, so path of 4 is still 5 over here. I want it to be 4, right? Okay, so now over here I'll check. Path of 4, 5 plus 3. Is it less than path of 5? Yes, So we will update this and it will become 8. Okay. Now we will go to second iteration. In second iteration, I will start again. Path of 1 will not change because 0 plus 4 less than 4. It is not true. Then path of 3. It will not change because 0 plus 6 is not less than 3. Alright. Now we will work with next one. Path of 1 plus 7 is less than path of 2. No. So we will not work for it. Then path of 2 plus minus 8. Is it less than path of 3? No. We will not update it. Path of 2 plus minus 2. Is it less than path of 5? No. So we will not update it. Okay. Then path of 3, that is 3 plus 2. Is it less than path of 4? No. So we will not update it. So this way we will keep on moving around the entire array. How many times? For n minus 1 times. That is 5 times. Okay, because in this case the value of n, or the value of vertices which we have, is 6. So we will go for 5 iterations. Okay. So this is how we are working. You saw in the case of 3 also that how the previous time we were able to get the answer or the shortest path in the third iteration. But when I changed the order which I chose, I got the answer in the first iteration itself. Right? So that is good enough evidence. 1, 2, 3, 4, 5. This is 0. 1, 2, 3, 4 and 5, and over here I have the 6th box also. Okay, so we will have a final array, but this position will not change. Over here this will not change. The rest will keep on changing while we take v minus 1 iterations. Okay. So now we need to discuss that why we take v minus 1 iteration. That was the question which was being asked in the beginning of the video itself. Why v minus 1? See, in a graph, there are two types. One is linear and one is cyclic. So when we are working with a linear graph, the number of edges which we have is equal to v minus 1 or vertices minus 1. You can take the example of a tree also. So if you have 3 vertices, you will have, if you have 4 vertices, you will have 3 edges. So this works for linear very well. Alright, but when we are working with a cyclic graph, let's suppose something like this. In the beginning itself, we talked about how we will never be able to work for a negative weight cycle. Why? Because it will keep on moving in multiple infinite loops, and if it will keep on going in loops, you will always have shorter answers. But why would you go in multiple loops, right? So it can never work for negative weight cycle. So let's suppose you need to go to 5 from 0 and all the values are positive over here. Okay. We cannot work for negative weight cycle. So let's suppose we are working only for the positive weight cycle. Now one way for you to go to 5 will be this, right? Then you may say that you want to go in a cycle. But my question is, why would you want to go in a cycle and increase the value of your path length if you can go directly? Right? If you take a cycle and all the values are positive only, then going in a cycle will just increase your path length and the cost as well. So why don't you go directly? Okay, so if you take a cycle approach when it comes to positive weight cycle, you will not get an optimized answer. That is the reason why we always travel linearly when it comes to our cyclic graph also. Okay, so in cyclic graph, if at all it came to your head that our path can be greater than v minus 1, It cannot be, because if you take more than v minus 1 edges also and more than v minus 1 path length also, then it will not be optimized, and you want optimized answer. So our path will be, maximum path length will be v minus 1 only. So path is less than equal to v minus 1, like we talked. Okay, so now we will try to code this. All right, I'll just minimize it over here. Okay, now let's see. Do not get rid of this. I'll just get rid of this part. We don't need this part. Okay, now we'll go and code this. So over here, when we are working, the first thing which I'll need is my path array, right? So we create a path array. Int path is equal to new int of size n. Okay, arrays dot fill path with, we filled it with infinite, right? Infinity. So integer dot max value. Okay, and I am saying that path of 0 will be 0 only. Now over here, what I've done is that over here, see over here, I have converted it to base 1. I have subtracted 1 from it, so I've converted it from base 1 to base 0. Why did I do this? Because I want to be able to calculate the minimum value. Alright, I want the minimum path, the shortest path, so I converted it into base 0. Then what I need to do is I need to take n minus 1 iterations, right? So we'll go for int I is equal to 0, I is less than n minus 1, I plus plus. Then I need to work I for n minus 1 times on all the edges again and again. So we will take for int j equals 0, j is less than, we took ARR, right? So we took ARR for our edges and ARR dot length. We will move on it. This array ARR is the representative for our edges array. All right, and we will increase this j plus plus. Okay, the next thing which we need to do is that we need to find out u, v and weight. U was the first vertex, v was the second vertex, wt was the weight between them. So we need int u, which we will get from array jth row and 0th column. Okay, int v we will get from array jth row and first column, and int weight will be equal to array of jth row and second column. Now we will check that if path of u is already infinity, right? So if it is equal to integer dot max value, what will you do in this case? If I have over here from 4 to 5, the weight I have gotten is minus 2. Let's suppose u, v and w. But in the array itself, on the 4th position, I have infinity. So if path of u is infinity, no matter what you add to it, it can never be less than path of v, right? So if you find such a condition, you will simply continue. Okay. And if path of u plus weight is less than path of v, then we will update the value, right? So it will become path of v is equal to path of u plus weight. Okay. Then the next thing which we need to do is, through this we will be able to completely modify the array the way we want it to be modified. The next thing which we need to do is we need to print, right? We need to print the values which are stored in the array. But the thing is, we don't need to print the value which is present at the 0th index, because as we discussed, it is always going to be 0 only. From 0 to 0, the shortest path will be 0 only. So we will start from int I equals 1. Okay, I will be less than n. All right, n over here, n we've taken as an input only. So I is less than n, I plus plus. Okay, in this we will check first that if there's still a position where we were not able to find out the shortest path. So if there's, we can only print, see, if I have this array, let's say it is of size 4 only. So over here I have 0. Let's suppose I got 3 here, 4 here, but infinity over here. So when I'll get to a position where I have infinity on the paths array, instead of printing infinite value, we will print 10 raised to power 9. Okay. So we will check first that if path of I is not equal to integer dot max value, only then I will print it. All right. So I will print system dot out dot print path of I along with a space. All right. And if not, then I will print system dot out dot print 1 2 3 4 5 6 7 8 9. All right, so we will print 10 raised to power 9, and then we will go to the next line. So system dot out dot print ln. Okay, so now we will try to run this, and we have an error. Let's see what it is. Okay, I did not put double equal to over here. Now we'll try to run this and submit. Okay, so we got the right answer. So we were discussing about Bellman 4 today. Okay, so I hope you were able to understand the question as well as the solution. And it is an important algorithm, so I request you to practice it properly. And the next question which we will do is an application of it. So please practice it properly. So thank you for watching the video. We will see each other the next time. Till then, please like, share and subscribe to the channel.